If we keep on the fan, there is a background noise, and I don't have any objection because that also cools me off. But I hope you are not enjoying the videos with the background noise. So I have tried to switch the fan off again. Let us see how long does this video hold before it gets very hot. So we have a similar sequential switching problem here. I have chosen the difficult ones so that you don't say that I solved the easier ones only. All these are from the exam basically, where there is sufficient time to solve such a question, even more time than I am taking in this video with all the explanation. So in this circuit, before this switching occurs, so this was here, this was here, and basically this was the circuit that we are initially concerned with. Okay, basically we have this problem of auto focusing, and I want to this not to occur. So without taking the pen to that area, I will try to explain that. So before t is equal to 0, or at t is equal to 0 minus, what do we have here? We are going to have this current source, this resistor, and an open here because the capacitor is being charged. So whatever will be the voltage is not given, but we will take it on our own. So VC at 0 minus is going to be, this current will all be flowing here, and the voltage across this one is going to be the voltage across this one. That comes out to be 20 milli into 0.5 K, which would be 10 volts. So the capacitor is has been charged up to 10 volts. So when this switching occurred, after switching for t greater than 0, or rather because of the sequential switching, let us write it like this: 0 is less than t is less than 2 seconds. So we are going to get this circuit. The other circuit is still not into play. Remember, this circuit is open because there is the switch is in this direction. So the inductor is not having any current through it. That is its state. So we have this VC here, initial value 10 volts, and we have a 2 millifarad capacitor and a 1 kilo ohm resistor, and we have to find the expression for VRT. Why? Because the question says, uh, okay, the question does not say anything about VRT. It says at what time. Oh, no, sorry, it's not about the capacitor, it's about this resistor. So at what time the voltage across the resistor would be 20 volts. So that's the question. So here you can see that the capacitor has been charged up to 10 volts. In this circuit, there is no chance that the resistor is going to have a voltage of 20 volt across it, because the max voltage in the circuit is 10 volts. Anyhow, let us try to solve this. This is a natural response circuit, and the expression for VCT or VRT, which is the same thing, will be, you can very easily imagine, is a natural response circuit. 10 initial voltage, e raised power minus t over tau, and tau is going to be 1 k into 2 milli k cancel, you are going to get 2. So this will be the voltage across the resistor, and no value of time is basically going to give us a value of 20 because it's an exponentially decaying one. Okay, that's okay. Then there is another switch that fires at 2. So basically after one time constant. So what will be the value of the capacitor voltage at 2 just before that switching occurs, which will obviously be the value after switching occurs, because it's the voltage across a capacitor. The voltage across the resistor may change because it's across a resistor, but across capacitor it will not change, and that would be e raised power 10 into e raised power minus 1, 2 over 2, whatever that value is. I think it is 0.632, so it will be 6.32. So uh, after the switching at 2 has occurred, how would the circuit be? where here we will have a capacitor. Okay, the value, sorry, I have not looked at the circuit carefully. This voltage across the capacitor after switching is not important. Why? The capacitor is being kicked out of the circuit because of that switching. So that switching connects that resistor to that circuit. So from the resistor point of view, the 1 kilo ohm resistor point of view, it is coming into this circuit, the force response circuit. So here we can very easily see that the resistor is going to get a voltage of 50 volt somewhere down the line. Why? Because in the steady state this is going to be shorted out, and then all this 50 volts is going to appear here, and before that somewhere it would pass the 20 volt point. So we need to find the expression for this VR. So what will be the initial value? Initially the inductor was because it has zero current means it was open. So initially this VR would be zero. After switching for this time, or rather let us say exactly at this time after switching, VRT would be 0. Why? Because the inductor current is 0. Inductor current is 0, no current here, no voltage. And what will be the VR final value? It will be, we know it will short out, and finally this current would be flowing here. So we are going to get 50 volt. All the current, all the voltage will appear here. So basically using the general solution, we are going to write the expression for VRT, and it will be final value minus initial value, sorry, plus minus the final value e raised power minus t over tau. Tau in this case would be L over R, and L is 4 Henry and this is 1000. We are going to get 0.004 seconds or 4 milliseconds of tau here. So we are going to get 0.004, or maybe this can be written as 51 minus E minus 250 maybe T, 2500 or 250, I think 250 T would be the value of the voltage. Now this is the expression for VRT, but this is not what the question asks. It asks the time at which VRT will be 20. So now we know VRT will be 20, and this is the expression. So we know that 1 minus e raised power minus 250 t would be 20 over 50 at that point. So, and we can solve this. E raised power minus 250 t would be equal to 1 minus 20 over 50, I think, which is 1 minus 0.4, which is 0.6. So e raised power minus 250 t is 0.6, and if we take the natural log of both sides, we are going to get minus 250 t is equal to natural log of 0.6, or t would be equal to natural log of 0.6 because it is less than 1, its value will be negative, minus 250, and this exactly is going to give us the time in second. So at this time we are going to get the value of voltage across the resistor of minus 20.